So this is the 60th video on Newton's laws of motion. In this video also I will take up a numerical question on Newton's laws of motion involving the concept of combined equation, constraint theory and pseudo force. Okay. First I'll draw the diagram of the situation. Diagram of the situation is as like this. This is a horizontal surface. This is a wedge. Mass of the wedge is 4m. This angle is 60 degree. This angle is 30 degree. Here a massless pulley is rigidly fixed to the wedge. A massless inextensible string passes over this pulley. And here two blocks are attached. Mass of the blocks are m and 2m. This string is parallel to this incline and this string is parallel to this incline. The string is massless and inextensible. There is no friction anywhere. This wedge of mass 4m is free to move on this smooth horizontal surface. This block of mass 2m can slide over the inclined face of this wedge. And this block of mass m can slide on the inclined face of this wedge. Okay, fine, alright. This is therefore the required given situation. The system is released from rest. To find the tension in this string. Okay, question write down here. Find the tension T in the string after the system is released from rest. Okay, find the tension T in the string after the system is released from rest. This T we have to determine. Okay, fine. So now how do we start? First of all, note this point that since the string is massless and there is no friction between string and the pulley in contact, tension at every point of the string is same, T say. Now what I do, see, let us denote this wedge by W. W means wedge. Let us assume the motion direction of wedge to be A. A is the acceleration of wedge with respect to ground after the system is released from rest. I have assumed A in rightward direction, okay. You can assume the motion direction leftward also. If on solving you get a negative sign, it means the direction of A is opposite to what I have assumed. Okay. Now I assume the acceleration of these two bodies with respect to wedge. Suppose B is the acceleration of 2m with respect to wedge. And C is the acceleration of m with respect to wedge. B and C will be equal. But I'll prove them using the constraint theory. So both this B is with respect to wedge W. And C is also with respect to wedge W. Okay. Now what I do, as I've stated just now, I'll prove that B and C will be equal using the constraint theory in the frame of the wedge. Alright. And A is the acceleration of wedge with respect to ground. Okay. Rightward direction assumed. Okay. Fine. Now what I do, I draw, let's label the block. Let's call this block of mass M as B1. And let us call the block of mass 2m as B2. Okay. Now what I do, I draw the free body of B1 and B2 with respect to wedge. Okay. So free body of B2. FBD of B2 with respect to wedge. FBD of B2 with respect to the wedge. Okay, fine. So this is block B2. This is its weight 2 mg. There is a tension T which acts on this block B2 due to string. There is a normal force N2 on block B2 due to the wedge. Wedge accelerates A rightward. So as seen from wedge, a pseudo force will act 2ma leftward. Fine. Because the wedge is a translating NIRF. Wedge is a translating non-inertial reference frame. Okay, fine. Now I write down the Newton's law equation of this B2 with respect to ground down the wedge in this direction. So what do I write? N2 will have no component in this direction. Only these three forces will have some component. So what do I say? 2ma cos 60 degree 1 by 2. 2mg sin 60 degree root 3 by 2. Minus T is equals to 2m times acceleration of B2 with respect to h down the incline, which is simply B. B. So this is the first equation. You can simplify it slightly. So it becomes MA plus NG root 3 minus T is 2MB. This is the first equation. Alright. MA plus NG root 3 minus T is equal to 2MB. This is the first equation which I have obtained. Fine. Now I draw the free body of B1 with respect to wedge. I show it here. This is the B1, block B1. What are the real forces? Mg. String exerts force T on block B1 in up the incline. Normal force on the block B1 due to wedge. Okay. Now wedge is a translating NIRF. So as seen from wedge, a pseudo force will act on this block M, whose magnitude will be MA, opposite to direction A, that is leftward. MA. Alright, fine. Now write down the Newton's law equation of block B1 with respect to wedge up the incline. So then N1 will have no component in this direction. Only these three forces will have some component, non-zero component. So what we write? T plus MA cos 30 degree. This angle is 30 degree, you can see it. MA cos 30 degree, MA root 3 by 2 minus MG sin 30 degree. MG sin theta is down the incline, so minus sin 30 becomes 1 by 2. That is just equal to how much? N times C. This is the second equation, C. So first equation was this one. 2MA by 2 plus 2MG root 3 by 2 minus T is equal to 2MB. And T plus MA root 3 by 2 minus MG by 2 equal to MC. This is the second equation. Alright, fine. Now I rub this one. Now what to do next? Tell me. Now, what I do now, I write down the combined equation of B1, B2 plus W in rightward direction. Okay. CE meaning combined equation. In case you have doubt regarding CE, just go to the 19th and 20th video on Newton's laws of motion. Playlist is I've added all those videos in playlist. You can go there and see it. So combined equation of motion of B1 plus B2 plus W along rightward direction. Combined equation of motion of B1 plus B2 plus W along rightward direction. Now, in combined equation, we know that only real external forces appear in the system, in the equations. So what I'll do, I'll draw the separate free body of B1, B2 and wedge separately with respect to ground frame. So see, this is the block B2. Here we get 2mg, here we get T, here we get N2. So you see, while drawing the FBD with respect to of separate bodies, they are all drawn with respect to ground in combined equation. So only real forces will act, no pseudo forces will act. Okay. So when I draw the FBD of B1 with respect to ground, mg, T, N and 1. Okay. Fine. Alright. Now I love this one. Alright. Now draw the free body of wedge with respect to ground, considering this pulley to be the part of the wedge. So see, this is the wedge 4M. Here 4mg acts. Here ground exerts normal force N on the wedge. Pulley is a part of the wedge. 2m exerts a normal force of N2 on the wedge as per Newton's third law. This M exerts a normal force N1 on the wedge opposite to this direction as per Newton's third law. And one more thing, this string which has a tension T, it effectively acts at 2 points of the pulley only, one this way T and one this way T. Okay, so these are the respective three free bodies of M, 2M and 4M with respect to ground. Alright, now we know that in combined equation only external forces appear, no internal forces appear. Now when we draw this FBT, what are the internal forces? N1 internal force gone, they will not appear in combined equation. N2 internal forces, they will not appear in combined equation, gone. This T and this T, internal forces, they will not appear in combined equation, gone. This T and this T, they are also internal forces between the block and the wedge, they will not appear in combined equation, gone. Okay, so we are left with only which forces? External forces only are 2 mg, mg, 4 mg, n, that's all. These are the only external forces on the system, B1 plus B2 plus W. Remaining all forces are internal forces. So only external forces on B1, B2 and W are this, this, this and this. Now all these external forces are in vertical direction, either downward or in upward. There is no external force on the system B1, B2 and W in rightward direction. So net external force on the system B1 plus B2 plus wedge with respect to ground in rightward direction is 0. Okay. Now that is equal to summation of mass times acceleration. First of all, wedge. What do you write for wedge? 4 ma plus. Now what about block B1? What do you write regarding block B1? Tell me. That will write as m times acceleration of B1 with respect to ground in this direction. Let us call this direction as x direction. I write down the name of the term here. X component of acceleration of block B1 with respect to ground, A B1 gx. X component of acceleration of B1 with respect to ground, A B1 gx. Plus. Now this block, 2m times x component of acceleration of block B2 with respect to ground, A B2 gx. Alright, fine. Now, I'll rub all this, okay? This I'll rub it. That is not of no use, okay? These two equations, I'll write it here so that I get more space to write there. ma plus mg root 3 minus t is equal to 2mb. This is the first equation. And second equation is this. T plus ma root 3 by 2 minus mg by 2 is equal to mc. This is the second equation. Alright. Now I have these two equations here. Now I write down this equation I have already written. This also I rub this, okay? You can see this m they go away common. 4a plus. Now what do you write this as? This we write using vector notation. We write a b1g dot I hat. What is I hat? I hat is the unit vector along rightward x-axis. Plus this was what? 2 times a b2g dot I hat. Alright. 0 is equal to 4a plus. So what about a b1g? This becomes a b1w plus a wg dot I hat plus 2 times this we use using the theory of mutually translating frames. A b2w plus a wg dot I hat. 0 is equal to 4a plus. Now what is a b1w? Acceleration of block B1 with respect to wedge, which is simply nothing but vector C. Vector C. AWG is nothing but vector A. Dot I hat. What about AB2W? AB2W is nothing but vector B. Acceleration of block B2 with respect to wedge, which is vector B. Thus AWG is nothing but vector A. Dot I hat. Alright, fine. Now I love this portion, alright. Now what do you get here? See, 0 is equal to 4a plus, see this I break using the distributive law of dot product. C dot a plus a dot I hat, c dot I hat plus a dot I hat plus 2 times b dot I hat 2 times a dot I hat. 0 is equal to 4a plus, what about c dot I hat? C is in this direction, I hat is that direction. Angle between c and I hat will be what? This is 30 angle 150 degree. So this becomes C into 1 into cos 150 degree. Cos 150 degree becomes minus root 3 by 2. A dot I hat, this becomes A into 1 into cos 0 degree. Cos 0 degree is 1. 2B dot I hat, B is in this direction. So B is this way, I hat, that angle will be 120 degree. So this becomes 2 into B into 1 into cos 120 degree, which is minus 1 by 2. Plus 2A dot I hat, that is nothing but vector 2A itself. 2 into A into 1 into cos 0 degree. So here we get 0 is equal to, how much do we get? 4A plus A plus 2A. How much it becomes? 7A. 7A. This 2 goes away. Minus B minus C root 3 by 2. Okay. This is what we get from the combined equation of motion. 4A plus A, 5A. 5A plus 2A, 7A. 7A minus B minus C root 3 by 2. So this is the third equation which I obtained. Okay. This equation also write it here. Alright, just like this simplified. So this becomes 7A is equal to B plus C root 3 by 2. This is the third equation. Alright. 4A and A, 5A into A, 7A. 7A is equal to B plus C root 3 by 2. Okay. So 3 equations we have written. Now how many unknowns are there? Count it. A, B, C and T. 4 unknowns are there. But we have written only 3 equations. We need at least one more equation to solve the problem completely. Okay. Now that will come from the theory of constraint. Alright. Now I have this one. Alright. Now, combined constraint equation is the consequence of fact that length of string is constant. This can be applied in any frame or reference. I write down the constraint equation simply in the frame of wedge. That is easiest. Easiest way you can get the relation between B and C. Okay. So I write down the constraint equation in frame of wedge. Alright. Constraint equation in wedge frame. Now see, in this problem there are no variable angles. So constraint relation for velocity, displacement and acceleration will be same in format, mathematical format. Since we are interested in relationship between accelerations, we directly use the concept sum of T dot A over all the bodies adds up to 0. Okay. Now see, there is only one string in the problem. This string. If you see, this string is something like this. Okay. Now this string exerts a force on 2m. T in upward direction. This string exerts force on this pulley at effectively 2 points. At this point T like this, and at this point T like this. And this string exerts a force on this block in up the incline T. Okay. So this string effectively acts on 4 points. One at this point, one at this point, and one at this point of pulley, and one at this point of pulley effectively. Okay. Now sum of T dot A for all these 4 points in the frame of wedge adds up to 0. Now see this, for this one, T acts in this way. With respect to wedge, this has acceleration of C up. So T dot C becomes TC cos 0 degree. Alright. Plus, now see this one. At this point T acts in this way. And in the frame of wedge, this point has 0 acceleration because pulley is rigidly fixed to the wedge. So this becomes T into 0, which is simply 0. Here also T acts in this way. And this point of pulley has 0 acceleration with respect to wedge. So T dot A again becomes T into 0. 0 into T, okay, fine. And here, T acts on this 2m in this direction. With respect to wedge, this has acceleration of B down the wedge. So it becomes TB cos 180 degree, which is minus 1. They all add up to 0. Now see, T and T will cancel out. So C becomes equal to B. In the beginning also I mentioned this point. In the beginning also I mentioned that B and C are equal. But I proved it formally using the constraint theory. Okay. Now it can be solved easily to obtain the answer. So now from what I do now is that B and C, I write it here, okay? B and C, they are equal. Now we have to determine a capital T from this equations. Now I rub this one, alright? Now question is how to solve such questions. That is the main point. Okay. So first what we do is that we have to find the value of t. No. Okay. So combine equations here. So replace c by b. Wherever c is there, we replace it by b. Okay. So in this second equation we get what? t plus ma root 3 by 2 minus mg by 2 is equal to mb, because b and c are equal, so this c has been replaced by b here, and this equation becomes what? ma plus mg root 3 minus t is equal to 2mb. Okay, and here also replace c by b. 7a is just equal to b plus b root 3 by 2. b plus b root 3 by 2. Okay, fine. Here 7a becomes b plus b root 3 by 2. Alright, fine. So now all you have to do is to solve this for a and b. So a and b relation I have obtained. I place a by this in here and here. From this you can see that I can remove b from this. Okay. From this equation you see how much will b going to be. Divide this by m. b will be obtained in terms of t and a. And replace this b here. Will be t and a to be obtained. So we will get a relation between t and a from these two. And then from we can get the value of t. Okay. So I'll replace this a by this, whichever is more convenient. Okay. So what I'll do, I'll just divide these two. This by this I divide, then and b goes away. We left only a. Okay. And then we can solve the problem. Okay. Fine. So now how do I solve it? Or what we can do is that I'll just add all of them, add both the equations. If we subtract these two equations, then it's better to solve this. Okay, fine. Okay, fine. All right. Okay. So so I'll replace b. Okay, I'll replace this a. Wait, just wait. Okay, fine. Okay, all right. I'm just solving it. Okay, just how to solve this problem. That's all. Just a matter of solving, nothing else. Just the equations have to be solved. That's all, nothing else. So t and b are t and b are 3 unknowns. So let us remove this a. Okay, let us remove this a from both these equations. This ma I substitute here. See, ma becomes t plus 2mb mg root 3. This becomes ma. T plus 2mb minus mg root 3. This is ma. This ma I substitute here. T plus root 3 by 2 ma. This ma I have obtained. T plus 2mb minus mg root 3. I substitute it here. T plus root 3 by 2 ma becomes t plus minus mg root 3. Okay. Minus mg by 2. Alright. Alright, fine. That is just equal to what? mb. Alright, fine. Now what do you get from this? What do you get from this? Tell me. So it becomes how much? This becomes t into 1 plus root 3 by 2 plus 2 cancels out, root 3 mb minus 3 mg by 2, root 3 into root 3, 3 mg by 2 minus mg by 2 becomes mb. Okay, fine. How much do we get? T into 1 plus root 3 by 2. This becomes how much? Minus 2 mg. This one. And I send this from that side. mb 1 minus root 3. Okay, fine. Alright. Now this also I have obtained. Now what I do, I replace this a, I put this a in this equation. Alright. I rub this one. Alright, fine. See, so now I put this A in this equation. Place this A in this equation, okay? So M times A becomes what? B by 7 plus B root 3 by 14, okay? A becomes B by 7 plus B root 3 by 14 plus mg root 3 minus T is equal to 2 mb. Alright, fine. So now we can eliminate B from these two equations. See, I take B that side, okay? How much it becomes? mb 2 minus 1 by 7 minus root 3 by 14, okay? mb I take common, 2 minus 1 by 7 minus root 3 by 14 is equal to mg root 3 minus T. Fine, alright. So mb I take common, 2 minus 1 by 7 minus root 3 by 14 is equal to mg root 3 minus T. Alright. Is it alright? I suppose it's fine, okay? So we get how much? 2, 7, 14. 13 by 7. We can say if I take 2 here, so 14 into 28 becomes how much? 13 by 7. 26 by 14. 26 minus 3 by 14 is equal to mg root 3 minus T. Okay? And this equation now from mb we will eliminate from these two equations. mb. I put this mb in this equation. Okay? So T into 1 plus root 3 by 2 minus 2 mg is equal to 1 minus root 3 into mb. mb I substitute this here. 14 into mg root 3 minus T by 26 minus root 3. So this is the required value of T. Okay, fine. I rub this one, alright? So now I solve this for T now, okay? So this T I bring this side and 2mg I shift that side. So this becomes T times common 1 plus root 3 by 2. T becomes common 1 plus root 3 by 2. Okay? This T I bring this side. Plus 1 minus root 3. 1 minus root 3 into 14 by 26 minus root 3. Okay? Fine. T is common throughout. T is common. 1 plus root 3 by 2 and then plus 14 times 1 minus root 3 by 26 minus root 3. Yes, very good. That is just equal to how much? That is just equal to 2 mg this side. 2 mg minus 14 mg root 3. 14 mg root 3 into root 3 minus 1 by 26 minus root 3. Alright. So from this you get the answer. 2 minus 14 root 3 minus 1 by 26 minus root 3 upon 1 plus root 3 by 2 minus 14 times root 3 minus 1 by 26 minus root 3. This is therefore the required answer. You should solve it on your own. Okay, leave it like this, there is no harm. It's a lengthy expression. That doesn't matter. See, main thing is you have to obtain the correct equation. Is it alright? I don't think there is any calculation mistake, but if there is any such calculation mistake, please rectify it. Okay, that's not a big issue. Alright, fine. So this problem also I illustrated a question involving the concept of combined equation, constraint theory for acceleration, and the pseudo force concept. Okay, so this you solve it. Okay, this has to be solved. There's no way out. It's a lengthy expression. You have to keep on solving. Then only when you solve it, you get the correct answer. I think it's alright. It's okay. If in case there is some calculation mistake, you just look into it. Fine. So this was 60th video on Newton's laws. This has solved this. Okay. So go through it. If you have any doubt, put your doubt in the comment box. I'll clarify it. Fine. I'll take 1-2 more videos on Newton's laws. Then I'll pass over to friction chapter. Okay. Friction also deal in great detail. Okay. So this I close it here. Fine. All.